can start off with what is Leap Motion. So it's a device that makes bringing your hands into virtual spaces possible. We're founded in 2010. It started as a desktop mouse and keyboard augmentation. In the last couple of years with the rise of VR and AR, we've pivoted towards that space, and it makes so much sense to have 3D input in a 3D output like VR or AR. So that's the focus of the company now. The way, what can you do with it is you can bring your hands into a virtual space. As I said, VR, AR, we also have developers doing things with Internet of Things, with robots, animation, a whole bunch of other stuff. Obviously, we're going to focus on VR today. Hardware breakdown of how does the device actually do this. So in the device itself, there are 3 infrared lights and 2 infrared cameras. Basically, the cameras pick up the infrared light that the lights are giving out, and from that black and white image, our software figures out the position and pose of your hand, knowing what a hand looks like, and does that 120 times a second. You just plug it in by USB, and at the moment, it's mounted to the front of an Oculus. Moving forward, we're looking at VR-specific hardware. We're looking at VR-specific hardware that won't be slapped onto the front of a headset. And the range of the device is basically 130 degrees. So the Oculus DK2, I think, is 100 or 110 degrees. So basically, when you can see your hand, it's tracked. And we're looking at expanding the tracking range, obviously. But right now, it's basically if you can see your hand, it's tracked. And we have support for a bunch of different languages, from C# for Unity, through Java, Python, Objective-C, a whole bunch of stuff. We're integrated in Unity. We have the most heavy support for, but we also have integrations for Unreal and a bunch of other things. So now we'll go to the fun part of what can you do with it. So here is a demo that I'm sure you heard about the 3D Jam that we're running. So last year for the 3D Jam, I made an application called Weightless, which I'll show you now. So, if I can talk while being in this, but try. So yeah, you can see, put my hands up, and they're tracked. Move them quickly, cross them over, they're still tracked. And in Weightless, you play with floating objects in zero gravity. And you can, the sensitivity and fidelity of the tracking is so precise that you can, basically with your fingertips, interact with and manipulate objects. Yeah, so you can move my hand through it, and it really feels like your hands are in VR with you, which is pretty amazing. So that's Weightless. But the basic interaction of that demo is actually really, really minimal. It's pretty much just using Unity's physics engine and the tracking provided by the Leap. So here is the prototype of Weightless, which is extremely basic. Which is just a cube in a room that you can bat around. And you can see interaction here is pretty much the same as Weightless. It's just in a nicer environment and with more context. But for the workshop, we're all going to build this prototype together in about 5 minutes. So just to show how quick and easy it is to get up and running in Unity with Leap and VR. So if you guys have, whoever's got computers and is going to follow along, what you got to do is open Unity, start a new project. And so we have a package called the Unity Core Assets, which are basically a package of the basics that you need to get up and running in Unity with Leap Motion. So if you've got Unity, I'm not sure how many people are following along, not that many, so I can run through this a bit faster. All you've got to do is open a new scene. So this is a completely blank project. Go to Assets, Import Package, Custom Package, navigate to where you have the materials, which I prepared earlier. Unity Workshop materials, there you go. And import the, oh, it's not there, it's in Unity stuff. And take the core assets and import them. Once you have that in the scene, it's pretty much drag and drop, and you'll have a scene that runs Leap and in VR. So this is going to take a second. So we have the core assets, which are the basic things that you need to get started. We also have a bunch of other smaller asset packages that do specific things for movement. So in weightless, the movement system is just putting up both of your hands and pushing forward. We have other packages for switching between AR and VR, and a whole bunch of other things. So this live demoing will import. What else can I tell you while this is happening? We also have a bunch of resources on YouTube of short tutorials like this that run you through how to get started. And on our blog, which I'll go through later, we have a bunch of tips specifically for motion control and human-computer interaction. This is definitely the longest this has ever taken. But we'll get there. So once it's imported, down here in the hierarchy, you'll see 4 folders, which contain everything you need to get started with Leap in VR. So we've got the Leap Motion folder, which has all of our materials, prefabs for hand controllers, and this is all basically the desktop assets that we have. And then in the Leap Motion plus OVR, we have the VR-specific prefabs and assets. And then the OVR folder is basically Oculus's package that we've got in there. So when you start a project, you don't need to download Oculus's package and ours. We've got it all packaged up together. And then plugins have all the API bindings for the tracking and everything else. So we're going to focus on the Leap Motion plus OVR. Jump down to prefabs. And then, so basically these prefabs are a virtual Oculus headset and a virtual Leap Motion controller. So if you just take one of these and drag it into the scene, make these icons a little bit smaller so you can see them. So what we've got here is we've got the left eye and right eye anchor with cameras, so that's from the Oculus. And then on the center eye anchor, we've got the head-mounted hand controller, which is basically the representation of the Leap in the Unity scene. What you can see here with this sort of frustrum situation is the limits of tracking of the Leap. So this is basically how far you can reach out in the virtual scene to give you a sense of scale. So from here, to get to the prototype that I just showed you, all we've got to do is jump over to Leap Motion prefabs and grab the hand controller sandbox, which is a prefab that just has just a room with some colliders, so also pretty simple. It comes also with a virtual Leap controller attached, and because we've already got one on the headset, we can delete that component. Get rid of that. And then we've got pretty much the virtual camera and virtual Leap, a box to put it in. Re-center it so it's sort of in there, and since no one's really following along that much, you can see where this is going. Move it around, resize it, position it so that it's in the center. Then add a cube. Do this and add a rigid body to it so that it has the physics engine recognize it. And once you have those 3 things, you hit play, and that's how easy it is to get started with Leap in VR. So we've gone from a new project to having VR and hands in a couple of minutes. And from there, basically, Weightless was taking this one mechanic and building an environment and a virtual space around it, and a narrative. And from that, from this simple prototype, that's pretty much it. So jumping back into the presentation. So yep, these slides will be available later, and this is step-by-step what I did, so you can follow along. We also have a video of this that we just posted to the YouTube channel, which does it in under 4 minutes. So Unity is free. You all have a device now. There's no excuse not to just get started with this stuff, and a Rift, hopefully. Yeah. No, so the default hand model, so I was going to go through it later, but I can jump into it now. So the default hand model that we're using now is, has actually, maybe I can show it to you. Stop playing this. So in the hand controller component, we have slots here for the left and right graphics, so how the hand is actually represented in the scene. And then we also have slots for the physics. So I'll go through the physics. So you can see here, that's why it moved over there. That's basically how the hand is being represented to the physics engine. So each joint is a cylindrical collider, and the hand is a box collider, which moves dynamically. But we also have like a bunch of different sorts of physics components, basically for whatever you want to be doing. At the moment, this is pretty blunt in that your hand is a bunch of boxes and it's interacting with other colliders. That's why in Weightless, when you try to grab something, it doesn't really work because a few reasons. Friction would have to have another layer to it if you wanted to code that into it. And secondly, because if you, in virtual space, try to grab an object, you don't have any resistance, so your hand usually goes through it. And that's a new sort of issue, design issue for motion control in VR, because you don't have any feedback, so users will normally just grab through something, and then the physics engine doesn't know how to reconcile two objects being in the same space, so normally some sort of glitch can happen. But we are working on a new thing called Interaction Engine, which is basically a layer on top of Unity's physics engine that dynamically generates anchor points on an object, which lets you grab it, basically. So it's a new layer of physics that we're working on. That's not ready yet, but it's in the works. Cool. Jump back over here. Yeah, so the prototype that we just went through is a really simple interaction. My background is actually not as a developer. I have an architecture background. Weightless was my second Unity project. And it's crazy to me how compelling these interactions are, basically just because we haven't been able to do them before. Without VR and now hand tracking being brought into it, it's just a really unexplored area that if you take one aspect of it and build it into an experience, it'll most likely be compelling. So I'm excited for all you guys to hopefully now be building and thinking about what you can do with just hands and VR. So to get you started on this idea that you just need a Spark as a foundation to build a great experience, these are the assets that I was talking about that we have outside of the core assets. So I'm going to go through and demo them to you guys real quick. So image hands is, actually that was in the current demo. So the way that you, this right here, the way that my hands are being represented in these examples is a new asset that we released called image hands. So the way that the sensor works is with the black and white infrared video feed. And what we're doing with image hands is we're not only tracking your hand and applying a rigged hand model, a 3D model to it. We're taking every frame, we're cutting out the video feed of your hand and then applying that to the physics model in Unity. So what you're getting is actually the black and white raw video feed on top of a physics model, meaning that when I put my hand up, I can see the ring on my finger and I know exactly what my hand looks like, and for you guys it'll be different. So we're getting closer and closer to it just being your hands in VR, which is cool. Quick switch is another thing that's made possible by the way that we're doing hand tracking. So So I can just not put it on. So this is basically the black and white video infrared feed that's coming from the sensor. And Quick Switch lets you, through a gesture of swiping down on the front of the headset, switch between AR and VR, essentially, which is also really cool and something that we haven't seen that many people pick up and use, but I think has as much potential as the VR applications of being able to quickly jump between, I can see, the real world and a virtual world and mix them sort of seamlessly through a device that's doing hand tracking, sort of a secondary additional feature of it. Sorry? So the way that it's, what it's picking up right now is the infrared light that's being emitted by the sensor. So unless we had really strong infrared lights that would then pick up, that won't be possible. But you can still see, I mean, there's some interference from here, but you can still see pretty far out. So you'd be able to avoid obstacles and that sort of thing, yeah. So that's image hands and Quick Switch, and then VR widgets. So some people have been asking basically, okay, cool, so I can see my hands, I'm in VR, but what about basic interactions that you might want to do in a space with your hands? And we figured that since we didn't need everybody to sort of do all the user testing and human-computer interaction research to just get a button and some basic sliders working, the front-end team built them so that you guys don't have to. So I can go over here, might have to go into the headset for this one. Do I need the mic? Oh wait, I can see the mic. Totally surprised myself with that, cool. So basically, these are utility widgets. We have buttons, so they have a couple of really cool features. So as I come at the button, it depresses slightly before it engages. The microphone is here. It depresses slightly before it engages and has this really tactile sort of feel that even though it's not really there, with all these visual cues and there's actual audio as well, you're giving all this feedback to the user that they're successfully completing an action, which is something that in VR is really tough to do, especially with motion control. So these buttons are very versatile. You can code whatever interaction or behavior you want as a result of these buttons. Similarly, we have this slider, which sort of does the same thing. Depresses slightly before it engages, and once it's engaged, I can move it back and forth. And then as an evolution of that, we have the scroll, there we go, which is basically a virtual touchscreen that has momentum and all the other things that we're used to from the 8 years that we've had touchscreens in our pockets. So these 3 widgets, you can just download them, same way that we dropped in the headset prefab. You can drop them into your project and have functioning UI elements instantly that you can make do whatever you want. So those are 3 of the additional Unity assets that we have on developer.leapmotion.com. There are, I think, like 15 or so, and all of them are interesting in some way. So I'd encourage you all to just go to the gallery, check them out, and see if one of them sparks an idea for an experience, hopefully for the jam. So jumping to what the title of this workshop actually was, I can't cover all of the possible things that are helpful when thinking about designing interactions for Leap Motion, but I'll cover 3 that are sort of obvious and ones that you should always have in the back of your mind. So tracking. We're always working on improving the tracking, and it's improved leaps and bounds since we initially released the device. But because it's an optical tracking solution, there's always going to be poses that track better than other poses. So the most confidently trackable pose is having your hand flat, facing the camera, facing the sensor, or facing away from the sensor with your fingers spread apart. Obviously, that's the easiest one for the sensor to pick up. As you move to hand poses where the camera sees less of the hand, it has to guess more about what the fingers are doing that it can't see. So a way to have the user have a positive experience is to design knowing the limitations of the sensor. So, for instance, not having an action where I have to grab something that's away from me, because once the sensor sees this, it's very difficult for it to know exactly what the fingers are doing, so it has to approximate. So it's something you can just have in the back of your mind. These are the best possible positions, and then build from that. Range and field of view. So if the user can't see their hand, or if the sensor can't see their hand, then they can't use it. It's obvious to us, but not obvious to some users. So a way to design with that in mind is not to have something, not to have an interaction where the user needs to be looking at something while interacting with something else that's in a different direction. Basically, because if the sensor can't see the hand, it doesn't exist because it's not tracked. So another really cool feature of image hands actually is, can I show it to you? I think I can. So another really cool feature of image, this isn't image hands, so I can't show it to you here. Basically the blue glow that you see around the hands, is a way of dynamically providing feedback about how confident the sensor is in its tracking at the current state. So when you have your hands flat and fingers splayed apart, the blue glow around your hands will be very bright. When you go into a pose that is not so confidently tracked, the blue glow fades away. So it's sort of a graphical way of telling the user which hand poses are tracked well and which ones aren't. So don't rely on that, but it's also a cool feature that image hands has. And then lastly, when talking about motion control, it's obvious you have to think about how people move. Weightless, some people played it for half an hour, 45 minutes, and didn't get really tired. Some people after 5 minutes sort of get the gorilla arm fatigue where they have to put their arms down. When we're moving from mouse and keyboard to this new virtual three-dimensional space, it's really important to think back just on ergonomics and how people move and what they find comfortable and not. So for example, the UI widgets, it's generally advisable to keep them sort of in the Goldilocks zone between desk height and eye level. So this is pretty comfortable. Above and below this can be a little bit harder on people. So those are 3 really quick tips. We have tons more on our blog, ranging from everything from just interaction design to what we've discovered about VR while building the UI widgets, and a bunch more just great content that is useful when you guys are developing your own apps. And then lastly, just go over the resources here. Developer.leapmotion.com is the hub for everything. It's where you can grab the SDK, the core assets that I dropped into the project before. The blog has articles on everything from the UX design tips to other cool integrations that people have made. And the VR gallery is where you can grab both executables of all of these great assets and the Unity packages that you can just drop straight into your projects. So, and also, sorry, on the gallery you can grab executables of most of the 3D Jam finalists from last year. I think we had 170 entrants. So there's a bunch of content out there also for you guys to get inspired by. Yeah, and so now was going to be building with people, but does anybody have any questions? You can field them for a little while. Yeah? Not really. So yeah, Unity 5, I'm sure you're like, Unity 5.1 has the VR features that are built into it. These things are happening so quickly that it's sort of like keeping up with the new Unity and the new Oculus SDK that did or didn't drop like a week ago. We are currently, I think, on 5.0. All of 5.0 is compatible with our stuff. The new VR mode will be once we update to 0.7 of Oculus. But besides that, which should be resolved in, I think, like a week, everything works with everything else. So, yeah. Any other questions? Yeah? To the gear. So yeah, great question. We have, so it's a USB device right now. We have an Android SDK that's in alpha that you can email us and request access to. It's obviously much harder, getting mobile to work with, even though the CPU consumption of the device is really low, getting it to work on mobile is obviously a lot harder. But yeah, this is a for now solution. So yeah, we're moving forward. Yeah. Yeah, also a great question. We've internally experimented with having multiple sensors. I think it improves tracking slightly, but not so much that it negates the disadvantages of having multiple devices. You sort of lose having the device tied to the headset allows freedom of movement where you're not like with the positional camera sort of stuck in an area. It's not something we officially support, but people have been sort of hacking it together as well. It's not in the API. People have tried to do it in some ways, but it's not officially supported, no. Yeah. Cool. No more questions. If you have another question, just come grab me afterwards. But yeah. Yeah, so I think probably similar question. Yeah, we've tried it, and yeah, it doesn't improve the tracking that much, but pretty much because we're building towards having the one sensor solution, so we've optimized for that. Yeah, yeah, yeah. Go for it. Mm-hmm. Yeah, totally. And that's literally the next bite-sized video that we're making, because that's something that, it's really easy to get right, but also easy to get wrong. So because it's using infrared light to do the tracking, obviously being next to a window or having the sunlight can interfere with it, because that's a huge source of infrared light. In general, regular lights don't affect it at all. So I won't demo it now, but unless the light is giving out infrared light, it shouldn't affect tracking. The biggest thing actually is because we're so used to sitting right in front of our monitors, most people put on a headset and the distance from the sensor to their hand is greater than the distance from their hand to their monitor. And so the device has a bit of trouble because the monitor is reflective, distinguishing between the hand and the monitor. So ideally, what you would want to do is take a big step back from your computer and recenter the rift so that you're a good distance back. And other than that, just being aware of the distance between the sensor and your hand should be smaller than the distance between your hand and any other background objects. And then it should be, I could, so not the nut, so that was made as an entry for the 3D Jam, and so I sort of cut some corners in the 6 weeks that I had. There's a chain object that you can put around your finger and like spin it around. It's basically how you model the object. So the nut is just a box collider. It doesn't have a ring of colliders around it, but if you wanted to model it that way, you could absolutely. Yeah, exactly. Yeah, it's up to the design of the experience. Yeah, the Leap is sensitive enough that you could do those sort of minute interactions. Yeah. Yeah. So haptics is obviously a super cool idea. It's still probably in like its absolute infancy because it's such a crazy thing to try to get right. We're not focusing on it because we're focusing on touchless optical solution and all the advantages of that. Not having to carry around a controller of any kind. There's a company called Glove One from Spain that has made a glove that has 10 vibration actuators in it, in the fingertips and then in the palm. And I think they have an IMU in the glove, so that's doing orientation and I think accelerometer. And they're using the Leap to do world space coordinates. So it's being tracked by the Leap and then also has its own tracking in it. Yeah. I think there's another company called Dexmo Robotics that has this exoskeleton around your hand, which can stop your hand from closing. But yeah, it's still very much in its infancy. Yeah. Yep. Yeah. So because it's capturing at 120 frames per second, it's pretty quick. The latency is really low as well. I would say in general, interactions are more precise when people are slower, so that's why we encourage it. It's not really a limit of the tracking as such, yeah. Cool. Any more questions? No? Okay, cool. Well, I'm excited to see you guys' entries.